Okay, we're going to be doing lead code 33, search in rotated sorted array. Do not do this unless you've done lead code 153, which is find minimum in rotated sorted array. So there's an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index k, possibly rotated, right? Meaning that there's a chance it wasn't even rotated, or it was rotated length of array times, which sets it back to a sorted position, sorted arrangement, such that the resulting array is blah blah blah, zero indexed. For example, this might be rotated at pivot index 3 and becomes 4, 5, 6, 7, right? What they mean is it was rotated 4 times, right? These 4 were put this side, right? So given the array nums after the possible rotation, remember it's a possible rotation, and an integer target, return the index of target if it is in nums, or -1 if it is not in nums. You must write an algorithm with log n runtime complexity. So the reason why they say possibly rotated is, as I showed you, what that means is that if it was rotated and it got distorted, it will end up like this. If it was rotated length of array times, it will come back to this. If it was not rotated, it will come back to this. So the way we solve this is by finding a pivot. And what will the pivot value be? The pivot value will be this position, the position at which it is distorted. And if we can identify this position, then we can binary search this side or this side. So actually your pivot value could be whichever you want. It could be either this or this, right? But once we find this location, it means we can binary search this side and this side, because this side is in ascending order sorted and this side is in ascending. Let me write it like this, because this side is in ascending sorted order and this side is also in ascending sorted order, right? So how do we identify this? If you've done lead code 153, you'll know how to find this pivot. We use a certain feature of this array in that all the numbers, right, the binary search to find the pivot is that all these numbers are greater than the last one here. So that means that we can use exhaustive binary search to exclude our I as long as it's in this position, i.e. array at I is greater than array at the last position, right? Otherwise, if it's sorted, our array at j, in other words, if it's like this, our I will remain at this position and our j will move all this way until here and will give us a negative pivot index, meaning that it was not changed. Either it was rotated 0 times or it was rotated length of array times. Right? So let's code this out. Okay, so we create a function to find the pivot index. We're going to call it def find pivot is equal to, we simply have an array and we have our I is equal to 0 Actually, to find the pivot, yeah, we have an array, we have a j is equal to length of array minus 1, and then while I is less than or equal to j, we calculate our mid, which is equal to I plus j divided by 2. Then we check if we are in the distorted portion. And by distorted portion, I mean this section. Sorry, fuck. I mean this portion, right? If we're in the distorted portion, then it means that if array at mid is greater than array at the last value, then our I is equal to mid plus 1. Else, we are in the proper ascending portion, which I'll call, by proper ascending portion, I mean this side, or this. So we decrement our j, right? Because we want our j to, after exhaustive binary search, to be either here or past this. Actually, I want it to be here or past this. So after exhaustive binary search, we return either I or j, right? Because after the exhaustive binary search, I will be here and j will be here. But for this, I'm going to return j. Right? Going to return j. It will be easier to work with. Actually, it's better to return j, because if it was still in this order, as I showed you, the j would be, if it was still sorted, then the j will come here, give us a -1, which we can use to identify that no, there was no pivot, right? So return j. So after that, we create a binary search function to binary search the whole array if there was no pivot, to search, or to search both halves in log n time if there was a pivot, right? So def binary search. So for binary search, we'll have an array, a starting index, an ending index, and then the target, which we'll call target val. So here, we'll simply say while our start is less than or equal to our end, we calculate our mid, which is equal to start plus end divided by 2. Then if array at mid is equal to target val, we simply return, what are we looking for exactly? We are looking for, okay, so we're looking for the index of the target, so we return mid, right? If array at mid is less than the target val, then we'd want our I to move forward, right? Else it means our array at mid is larger than target val, so I want to go to the portion where it's most likely to end up, mid minus 1. And then if we can't find it, we can't find it, we return -1. Right? So now that we have these two functions, we call to find the pivot index, right? So we say pivot index is equal to find pivot of nums, right? So now that we found our pivot index, we will create, we will check if pivot index is -1. If it is, then we are simply binary searching the whole array. The whole array, because it means that our array is in sorted order. So if pivot index is equal to -1, then we simply return binary search of nums starting index 0, length of array -1, and then the target as the target file. Else, it means we have a pivot index, and as such, we have to check either halves, right? So we'll check the first half. We check the first half, right? So left portion result is equal to binary search nums from which section? From 0 to pivot index and then target, right? Then if left portion result does not equal to -1, we return left portion result, right? Because it means that we found it. Otherwise, right portion result is equal to binary search nums from pivot index +1 till length of nums -1 and the target. Then at this point, if you haven't done this and you haven't found it in the left portion, then whatever result you get here will be the answer. You'll either find it or you will return -1. So you return right portion result. So essentially what we're doing here is we're binary searching this portion to see if we find the target and then return its index, right? So this should work. Oh man, it's taking too long, meaning I made a mistake somewhere here. So another way of doing this is, okay, I'm going to copy. Okay, so the issue with this is here. This code here can be a bit tricky. So if pivot index is, okay, we can just do it like this. Right, so if pivot index maybe we don't need to do it like, we don't have to write that, the else condition here. I'm going to just check this. Yeah, so it's something to do with this code. Okay, how do we do this? If pivot index is equal to -1, that's fine. Then you simply rotate the whole, otherwise left return. Okay, I'm just going to look at one of my submissions, which should have the correct code. So what I did was, if pivot index does not equal. So this is what I did, right? Let me see, how can I adjust this? Okay, if right portion result does not equal to -1, then return right portion result, otherwise you return -1. This may be the issue here. Nope, it's not solving it. So the only solution is this. So now this should work. Huh. That means I made a mistake somewhere here. Maybe in getting the binary search or the pivot index. No, this is fine. Binary search array start and target file. So while start. So this could have been an issue with the binary search. Okay, I think I made a mistake with the binary search actually. Yeah, so I made a mistake with the binary search. So sorry about that. So all the code I wrote before was fine, but I made a mistake with the binary search. I wonder how. Okay, so I is equal to start, and then j is equal to end. How could I? So I made a mistake with the binary search, but that's so simple. So I is equal to start, j is equal to end. Yeah, so otherwise the rest of the code I had written here was fine. The issue was with the binary search. Unbelievable. Alright, portion result is not defined. Global name if that is weird because this code just worked. So yeah, I had made a mistake with the binary search. Right, otherwise it works. Yeah, so I made a mistake here. Supposed to use these. Anyways, this is the code I wrote, so yeah. It's not good to spend too much time on a single problem, so yeah, this is it. So yeah, so this is the solution. It's a lot of code, so you can make some mistakes, honestly, but you just need to show the logic then. Yeah. So I think maybe my return statement was to the left or something like that. Yeah, probably that was it. Like my return statement was probably to the left. So yeah, thank you. And this is the solution. Bye.